always, I would like for you guys to be on the side that says humidity notes. Ooh, voice crack. Humidity notes up at the top. There's about 4 vocab words that we need to go through. Then there are 4 big ideas about humidity that I'm going to need you guys to know about. Once we do those, I'm going to go kind of quick because the tricky part with this is you have to know a little bit about all 4 of those big ideas to tie them all together. So it's going to seem really quick at first. It's going to seem a little overwhelming with a lot of info coming at you. But it starts to make more sense once you can actually start using that information and trying to work out the problems with that information rather than just listening to me drone on and on about the information. So, vocab word number 1. I have the definition right down. You're going to just write down the word, right? So when we talk about the amount of water vapor that we have in the atmosphere, that is talking about humidity. So humidity is going to be that first vocab word. Minnesotans deal with humidity a lot in the summertime, right? Summertime is where we usually think about this, but we have these different levels of humidity all year long. We're just talking about how much of that water vapor we have in the atmosphere around us. But it seems more relevant to us in the spring/summertime, which is almost here.
This winter went by fast.
Well, keep in mind this is like the fake spring, right? This is like the first spring. There's still gonna be another winter, and then we'll have real spring. This is just the time of year that I hate Minnesota because my dog is a mud pit every time I have to go down to use the
Every
bathroom.
time.
It's not
And
great.
then it's gonna
We have
snow.
pool puddles.
It'll snow one time and it'll be like 3 to 4
I've
inches.
had my dog
I
pretty
never
bad.
had one.
My weather says it's just gonna rain.
I don't like
new problems.
We have pool
I don't
puddles.
trust it.
Alright.
Tomorrow.
Second vocab word. So humidity is talking about how much water vapor is in the atmosphere. Relative humidity is something that's different. Relative humidity is going to be a ratio or a percentage of the air that is full of water vapor. Percentage of air that is full of water vapor. This is the one that meteorologists are going to talk about when they're giving their weather reports. They're going to pull maps up that look like this, and they're going to say the relative humidity in your area today is 70%. Okay, relative humidity in this area is 48%. Relative humidity is 100%. We're going to talk about what that means, okay? But since it's a percentage, it's going to be somewhere between 0 to 100, looking at what percentage of that air is full of water. Right? If it gets to 100%, that means that it's all the way filled up. Can't put any more in there. Okay? Relative humidity. Third vocab word, saturated. This is obviously not just a science word, right? Saturated is in all sorts of different areas of study that we're looking at here. But when we talk about saturated, we're talking about how the air cannot hold any more moisture. It's all the way filled up. We're at 100% humidity. There's no space for any more water, right? So if we tried to add more water into that atmosphere, if we were already at 100% humidity and we tried to add more water into that atmosphere, what's likely going to happen? That water's going to have to come out of the sky, right? Rain, snow, sleet, some sort of precipitation, some sort of moisture is going to have to come out of the sky, right? Because that air just can't hold anymore. Dan?
So if a city per se has 100% humidity, would it be like a sauna outside?
Basically, right? It would be it can appear as different things, and it kind of depends on other weather situations that are going on. But maybe it's going to be one of those days where there's just like fog sitting there the whole day. Maybe it's going to actually be raining outside because it's got to drop some of that precipitation out of the sky. We're going to look at some weather maps potentially later this week, but for sure next week, looking at what's going on with those different saturation levels. Yeah. There.
How do we get hail? Because hail's ice, but in the summer, sometimes we get hail.
Right.
But it's
So we're
over
gonna
32 degrees.
let me talk about that next week when I talk about updrafts and different weather situations that come along with different air masses. We're going to get there though, but that's a good question. It's a good question. All right, saturated. We're good? Just means it's full, 100%.
We're saturated of saturated.
Huh?
We are saturated of saturated.
You're saturated of saturated.
Yes.
Excellent. Last vocab word, dew point. This one is a good, this one's going to be really important.
I hate dew.
hate Mountain
It
Dew.
makes you throw your pencil, you hate it so much, huh?
Yep.
It's the worst, okay? When we say dew point is going to be a temperature, so it's gonna be 76 degrees, 87 degrees, right? It's gonna be some temperature. Dew point is gonna be the temperature that air has to cool to, that the air temperature has to come down to in order for the air to be saturated, in order for it to be at 100%, right? The dew point is always gonna be lower than the regular air temperature. So Derek right away saw dew point, I hate dew, right? So dew is gonna be that moisture on the grass, usually found in the mornings, right? And you get up early in the morning in the spring or the summer, right? You go outside and you walk in the grass and your feet or your shoes just are soaking wet. It's gross. I agree. It's the worst, right? And we get that dew on the grass because overnight those temperatures usually drop, right? And when those temperatures drop, they come down. We usually get to that temperature where that air becomes saturated. That air can't hold any more water, and some of that water has to come out of the air. And that water comes out of the air and collects on things like the grass. Or sometimes spider webs will look really cool with kind of all that dew kind of collecting on them, right? It's gonna that water is going to condense or collect on those different surfaces that are outside. It all has to do with that temperature coming down to that dew point where that water is going to come out of the air. We're gonna deal with more with that tomorrow and Friday probably. Alright, those are the 4 vocab words, right? Now we're moving on to those 4 big ideas that are underneath there. Just like we had 4 big ideas with air pressure that we practiced with, we've got 4 big ideas with humidity that we're going to kind of use to help us better understand some of these situations around us. Big idea number 1. This graph is already on there. You're writing down the big idea that's in red, right? This graph is trying to show you that big idea number 1 tells us that humidity is high in the morning. Humidity is usually highest in the morning and typically decreases throughout the day. Now I say typically because science always gives us these weird what if situations. That's just how science is. There's always these what if things that happen with it, right? But typically, on average, humidity is higher in the morning. That's why we see things like dew on the grass. That's why fog will sometimes be it'll be really foggy in the morning, but it'll clear up as the day goes on. Because that humidity is usually highest in the morning. Big idea number 1. Big idea number 2. Humidity is going to be 100% when air temperature and dew point are the same. And that's what this graph tries to show you.
What do you mean tries to?
Well, I mean, it all depends on whether you can interpret that graph, right? And on your paper, it's in black and white versus color up here on the screen, right?
Yeah.
Okay. So this graph is trying to show you that when air temperature and dew point temperature are the same, so that's why it's at 0, 0, 5, 5, 10, 10, 15, 15, right? As dew point and air temperature are the same, we have a 100% relative humidity. As those temperatures get further and further apart, as the air temperature and dew point temperature get further apart from one another, that relative humidity is going to decrease, decrease, decrease. When air temperature and dew point are the same, our air is fully saturated, it's at 100%. Alright, big idea number 3. Like I said, I'm going to go quick through these because we have to know a little bit of all of them to help us understand one another, okay? Big idea number 3. The closer the air temperature and dew point are, the higher the humidity we're going to be experiencing. So the closer the air temperature and the dew point temperature, the more close those two numbers are to one another, the higher that humidity is going to be. So the further apart they are, the lower the humidity is going to be. So that's what this graph is showing us, right? This is telling us the difference between that air temp and dew temperature. So as that difference gets larger, our humidity level is decreasing. All right, big idea number 4. Warm air holds more water vapor than cold air. The more you start thinking about these things and the more you start interacting with these, the more you're gonna be like, oh, this totally makes sense because you have experienced these things, you guys, right? We know that in the summer, there is more moisture in the air than there is in the winter. That's why in the wintertime, a lot of people have more issues with dry or cracked skin, or chapstick being needed, right? Or even people's hair acts differently in the summer than it does in the winter because of the amount of moisture that we have in the air around us. Cold air holds very little moisture, so the air feels very dry. Feel a lot more static electricity because of that dryness that's happening in the air as well. Summertime with warmer temperatures, that air can hold more moisture in that air. 4 big ideas. We're good so far? Okay. Last thing I'm going to talk about before we get working on our assignment. We have to be able to measure relative humidity. So we measure relative humidity using something called a hygrometer or a psychrometer. There's a ton of different varieties of them that exist out there. This is one example, okay? And the basic idea behind these tools to measure relative humidity is you have a device and it has 2 different thermometers on there. We call one of them is going to be the dry bulb and one of them is the wet bulb because they are literally, one is dry and one has this little like cotton wick on it that's in this container of water, right? So it's just wet, okay? And the fact that this one is wet tells us what the dew point temperature is of our room. So if I look at this one right now, it says that the air temperature of this room is 70 degrees and the dew point temperature of this room is 62 degrees, okay? So if we can look at those 2 items on there, knowing our wet bulb temperature and our dry bulb temperature, it lets us use something called a relative humidity chart to understand the percentage of moisture that we have in our air. So that's where this relative humidity chart is going to come into play. I have a paper copy that we're going to use while we're here in class. You don't want to keep this because why would you want to keep a relative humidity chart? So you're going to use it while you're here and then you're going to leave it on my back counter when you're done with it so I could just keep using the same one over and over and over again. If you're like you, that's gross, Mrs. C. I also have this digitally in Canvas. You can also look at it there if you feel strongly about that. I personally usually like paper just because it's there in front of you and it's sometimes a little bit easier to see and work with. So I'm gonna talk about how you use this chart and then we're gonna do that sheet, yeah. That's a lot of numbers.
Can you read that small font?
No, he needs glasses.
All right. All right, so looking at this relative humidity chart, so people at home, this, like I said, this is found in Canvas, so you guys are going to need to go ahead and find this relative humidity chart in Canvas so that you guys can make sure you understand how to use it. This is going to be something that I expect that you guys can use. You are going to have to be able to use a relative humidity chart on the test eventually, all right? So looking at this, all right, this relative humidity chart, like I said, we have to know our dry bulb reading, and if you look at this, we have our dry bulb reading across the top. So it starts from 34 degrees over here, and it goes all the way up to 120 degrees. So these temperatures are across the top. That's just asking you what the temperature is of the room, the actual temperature, okay? You're going to look at the actual temperature of the room, and then you're going to compare it over here where it says the depression of the wet bulb. When we say depression, we mean how much of a difference there is between the dry bulb and the wet bulb, okay? So for our room right here, we talked about how the dry bulb temperature was 70 degrees Fahrenheit. We said that the wet bulb reading was, what did I say, 62 degrees Fahrenheit? Was 62 degrees Fahrenheit. So step number 1 is going to be to figure out what the difference is between those two, right? So we're going to subtract those two. So the difference between those two should be 8 degrees Fahrenheit. So this is that depression or difference, right? We're going to need this number, and we need our dry bulb reading. Once we have those two, then we're going to use this chart. We're going to find where 70 degrees is on our chart, which is right here. I know these numbers are tiny. That's why the digital one might be helpful too, because you can look, zoom in on that document. But you find 70 degrees, and then you have to find where that 8 degree depression is. I suggest using some sort of a straight edge to kind of follow it along. So I'm going to put this underneath that 8, right? Because we said it was 8 degrees depression. And we're going to follow that over to where it was 70 degrees Fahrenheit. So the relative humidity of this room should be 63%. So the air in this room is 63% full of water. Right? You guys see how that's working? Yeah. Okay, so then your guys' task for the remainder of this 8 minutes. On the other side of your notes page, you are going to take a trip to Christensenville. Yay! Okay. Christensenville has some different locations throughout town. I have a pond, I have a forest, I have a library, I have my own bowling alley, and I have my own indoor water park. It's a pretty sweet place, okay? Before you start thinking of, or before you start actually working out the problems, I want you to make a prediction. Which location do you predict will have the highest relative humidity? Which one do you think will have the highest percentage of moisture in its air? And give me a short reason why, okay? So you're going to take your best guess, you're going to tell me why. Then you're going to use this chart to go ahead and figure out the relative humidity of these 5 locations. There are 7 questions to answer. This is your task to get this done before I see you in class tomorrow. I do not mind if you work together, but this is what I need to have happen.
Can we go to lab tables?
You can go to lab tables.
Lab tables.